Hi guys, in this lesson we are going to talk about data structures that we didn't discuss before. By data structure we mean a way to organize and store data so that it can be accessed and modified efficiently. So let's get started. V1 equal bytes, parentheses, square brackets, 72, comma, 101, comma, 108, comma, 108, comma, 111. New line, print, parentheses, type, parentheses, B1, comma, B1. And let's run it. As you can see, we created our first object of type bytes, which is very similar in many aspects to a tuple because it's an immutable collection of elements. So let's try doing something with this bytes object. Print, parentheses, b1, square brackets, 0. New line, print, parentheses, b1 dot find, parentheses, b, quotation marks, o. And let's run it. As you can see, we printed the first element of the collection and we also printed the index of the element we wanted. Now let's try to create another bytes object. b2 equal b, quotation marks, hello world. New line, print, parentheses, type, parentheses, b2, comma, b2. And let's run it again. And as you can see, we created another bytes object. Now let's use the bytes function to convert a string. S1 equal, quotation marks, Python. New line, b3 equal, bytes, parentheses, S1, comma, quotation marks, UTF, hyphen, 8. New line, print, parentheses, type, parentheses, b3, comma, b3. So it works. Now let's explore the next topic, Bytearray, which contains the same type of data as bytes object, but is mutable and manageable like a list. So b equal Bytearray, parentheses, square brackets, 72, comma, 101, comma, 108, comma, 108, comma, 111. New line, print, parentheses, type, parentheses, b, comma, b. As you can see, that's our first byte array. So let's try to update it. b, square brackets, 0, equal 74. Print, parentheses, b. And as you can see, we changed the first letter. New line, b dot append, parentheses, 33. New line, print, parentheses, b. And as you can see, we added an element to this collection. So new line, b dot pop, parentheses, new line, print, parentheses, b. And using pop, we removed the last element. b dot extend, parentheses, b. New line, print, parentheses, b. As you can see, it is very similar to a list. Now let's talk about stacks, which are data structures that follow the last in, first out LIFO principle, meaning the last item added is the first one to be removed. Stack equal square brackets. So we are going to simulate a stack-like structure using a list. Stack dot append parentheses quotation marks a. New line, print parentheses type parentheses stack, comma stack. And let's run it. As you can see, this stack is a list, but as long as we only use the append method to add elements, we can say it behaves like a stack. Stack dot append parentheses quotation marks b. Let's copy this line and let's change it. C. New line, print parentheses stack. It behaves as a stack. So, if append is the method to add elements, which method do we use to remove elements? Let's see. So, stack dot pop parentheses new line print parentheses stack. So, by using these two methods, append to add and pop without parameters to remove elements, we are managing a stack while respecting the last in, first out LIFO rule. Now let's talk about queue. Queue equal queue. Parentheses, new line, print, parentheses, type, parentheses, queue, comma, queue dot queue. And let's run it. As you can see, we created our first queue. Let's do something with it. New line, queue dot put parentheses quotation marks 1. New line, print parentheses queue dot queue. A queue also follows a rule similar to that of a stack, but instead it uses the first in, first out FIFO principle. Now let's copy this line and add other two elements. 3, 2. So we discovered the method to add elements. Now, what's the method to remove them? Let's see. Queue dot get parentheses new line print parentheses queue dot queue. Let's copy these lines and let's run it. And as you can see, we removed two elements from the queue following the first in, first out FIFO rule, leaving only the last element we inserted. So now let's talk another structure, which is a linked list. We need to create two classes. Class, node, column, new line, def, init. Let's add data and self dot data equal data. Self dot next equal none. Let's create the other class. Class linked list. Column, new line, def, double underscore, init, self dot head equal none. A linked list is composed of multiple nodes, where each node points to the next one until the last node points to none. So let's create a linked list, L equal linked list, parentheses, and let's create a node. N1 equal node, parentheses, 1. L dot head equal N1. New line, print, parentheses, L dot head, comma, L dot head dot next. You can think of this as the address where the object is stored, and none as the next location, meaning there is no next element, so there is no address to point to. So let's create other nodes, N2 equal node, parentheses, 2. New line, N3 equal node, parentheses, 3. And now let's connect those to the linked list. L dot head dot next equal N2. New line, N2 dot next equal N3. And let's print all the nodes. New line, print, parentheses, N1, comma, N1 dot next. Let's copy this line twice and set this to 3 and this 2 and again this 2 and 3, and let's run it. And as you can see, this is the address of the object and this is the address of the next one, which as you can see matches the actual address of the next object, and so on, till the none. So how to print the list easily? Let's do it. Current equal N1. New line, while current column, new line, print, parentheses, current dot data, comma, and equal, quotation marks, hyphen, greater than, new line, current equal, current dot next. New line, else, column, new line, print, parentheses, current. And let's run it. As you can see, these are the data contained in any node, the first, the second, the third. So let's recap. Lesson 28 hyphen data structure. New line, we learn about bytes, byte arrays, stack, which remember LIFO, last in first out, Q, FIFO, first in first out, and linked list. For this lesson it's enough. Thanks for watching and see you in the next lesson.